Hand this to Courtney. Hand this to Courtney. Hand this to Courtney. Courtney? Courtney's not here. Hand this back. Courtney's not here. Courtney's not here. Courtney's not here. Courtney's not here. You can go ahead.
Hello, I'm Courtney. Still look familiar, eh? The stomata, the xylem, the phloem, the capillaries, the oxygen, the carbon dioxide, the arteries, the veins. To you might be like, why does it all matter? But I'll let you all know right now, they're essential features to transport systems in plants and animals. And don't you forget it.
Our bodies have what we call a double circulated system. This means that it's driven by the systematic and pulmonary circuit. But what does this mean? In the pulmonary circuit, our oxygenated blood are provided to the left side of our heart. But in our systematic circuit, oxygenated blood is provided to the tissues within our bodies. And it all starts with one breath. Oh wow, it really feels like my right ventricle is contracting. So starting with the contraction of the right ventricle, we have deoxygenated blood is pumped via the lungs to the pulmonary artery where gas exchange occurs in the lungs. So here we have CO2 being unloaded and O2 being loaded. Then oxygenated blood is then carried back to the left atrium by the pulmonary vein. So here we're going through the pulmonary vein to the left atrium. Then we're going to have the contraction of the ventricle pumps the oxygenated blood out of the heart, and then the aorta is going to transport the blood to the rest of the body through the capillaries. The oxygen in the blood is then diffused throughout the body, and then CO2 is gained. So here, putting down the oxygen and picking up the CO2. Then the blood is then travel back through the superior and inferior vena cava back to the right atrium. So once we get back to the right atrium. Now we're going to go back to the right ventricle. And this is where the process will start again. So now we know the path of blood in the mammalian cardiovascular system. But what about in plants? Well, in plants, water and minerals are transported from roots to shoots by the xylem, and sucrose is transported by source to sink by the phloem. Come with me to trace the path of water movement in the leaves. So, let's trace the path of water movement in the leaves. The water will enter the leaf in the xylem of a vein. The water will exit the xylem and enter the walls of surrounding cells. So going in will then exit to surrounding cells around the xylem. The water will then spread as a film in and on the surface of the mesophyll cell walls. So we see this here and here, but we also see it specifically here. The water will then evaporate from the surface of the mesophyll cells and diffuse to the air spaces of the leaf, and then exit the leaf through the stomata.
Okay, but how is all that related to gas transport?
It goes through the vascular transport system.
Huh? Who is that?
I'm the version of you that studied.
Oh.
But the vascular transport system is the most efficient way for gas and other essential nutrients to be transported to the body cells of both plants and animals.
So, how does the structure of those vessels differ to support the function of both plants and animals?
Well, for plants, they contain xylem and phloem.
Which is used in photosynthesis.
No. As we previously said, the xylem moves water and some nutrients from the roots of the plants upwards to the shoots. The sheath of the xylem is formed of dead, hollowed out plant cells, which are perfect for the adhesion of water to its walls, which help propel the water movement up the plant, as well as cohesion.
And phloem transports sucrose?
Which goes from source to sink.
like sugar going from a leaf to an apple, right?
Exactly. Unlike the xylem, the phloem bundle is made up of living cells known as sieve cells, which are attached to the companion cells that run most of the cell's metabolic functions so it can focus on pumping sugars where they need to go.
All right, so I've got plants. What about animals?
Well, animals have arteries, veins, capillaries, and lymphatics to support the transport of materials throughout the body.
Wait, I think I know this. The arteries pump blood away from the heart, right?
Yup. And they have a thicker muscular wall and smaller lumen to increase the pressure in which oxygenated blood is moved to the rest of the body.
And the veins move blood towards the heart with valves to prevent backflow.
That's right. They have lower pressure than the arteries, but have skeletal muscles helping to contract and pump blood back to the heart, where it belongs.
And capillaries are the smallest vessels. They diffuse the most material to body cells.
They can do that through their thin membrane walls and increased surface area.
Okay, so we've been talking about the blood so far, which I know transports oxygen, removes carbon dioxide, and brings nutrients to the body cells, but what about the lymphatics?
The lymphatic vessels are responsible for taking up waste and the transport of fat, as seen here. They help recover leaked fluids from the cardiovascular system and bring it up to the large vessels in the neck, or the lymph nodes.
So the cardiovascular system is running the main operation here. Does the fluid it runs change directions like the phloem?
Actually, blood runs unidirectionally, driven by a high amount of pressure by the blood, which is why arteries have such thick walls. It's because of that high blood velocity and contraction, and, well, a vein has valves.
Oh, thank you for explaining. That was really helpful.
I'm really happy, but you should probably study though. It's really late. You don't want to end up like me.
I will. In an hour or two.
Okay.
What a race. We saw speed, we saw endurance, and we saw teamwork like never before. But now, let's hear from our racers. What makes your transport system the best? That was intense. But let's be real. Blood flow is built for speed. My system is all about double circulation, meaning I get 2 power boosts every cycle. Check it. In double circulation, I go through 2 loops, one for the lungs and one for the body. I start the right atrium. This means I'm low on oxygen and I gotta recharge. Then I move to the right ventricle, where I get pumped to the lungs. The left atrium welcomes me back, full of oxygen. Then the left ventricle sends me through the aorta to fuel the rest of the body. I drop off some oxygen, I pick up some waste, and I start all over again. And of course, I can't forget about my fishy friends. There, I only pass through the heart once. This works, but it's much slower than mammals. Double circulation gives more power and pressure. Now, if you'll excuse me, I'm gonna go load up on some oxygen. Next, we'll be talking to Team Xylem. I may not be the fastest, but let's talk endurance, baby. I never stop moving, and best of all, I don't need any extra energy to do it. I move up the plant using the power of transpiration. Water evaporates from the leaves and pulls me up like a giant straw effect. You might be wondering what keeps me moving up without falling back down. 2 words, cohesion and adhesion. Cohesion is when water molecules stick together, so we pull each other up, and adhesion is when we stick to the xylem walls so we don't fall back down. Now, let's say we run out of water. That's a little bit of an issue. If there's a drought, the stomata close up to save water, but that also means that I stop moving until the plant gets some more water. I'm energy efficient, but water dependent. And phloem, what about you? Listen, I may not be the fastest or the most low maintenance, but I am the most versatile transport system. I move sugar up and down, unlike these one-way travelers. They call it source to sink. Source being the leaves, where sugar is made through photosynthesis, and sink being roots, fruits, or anything that needs sugar. The sugar moves through me, phloem, using pressure flow. To keep things moving, I use a pressure gradient. Leaves pump sugar into me using energy, or ATP. Water follows by osmosis, creating pressure that pushes me toward the sink. Unlike xylem, I don't like to sit back and just let things happen. I like ATP and enzymes, and I want to keep the sugar flowing where it's needed. Oh, and I'm adaptable, versatile. I deliver sugar anywhere it's needed, no questions asked. What a great breakdown. Let's sum up our champions. Our fastest transport, double circulation blood flow, 2 loops equals twice the power. Our most energy efficient is xylem. Water moves up with 0 energy. Our most adaptable and versatile, phloem. Sugar on demand anywhere you need it. Folks, that is all for today for the Great Transport Race. Stay hydrated, eat your greens, keep that heart pumping. Science is cool. See y'all later.
All aboard! The apoplastic train is now leaving the station. Attention all passengers. Being on the apoplastic train, we transport minerals through the cell wall. All aboard! The symplastic train is now making its way through the cytoplasm.
Deja, stop doing bubbles in your drink.
You're right. You know what this reminds me of? Blood pressure. Blood pressure pushes the fluid outside of the capillaries. Just how I was blowing air outside of the straw into the water, that's what blood pressure does as well. Now, with all that being said, I think I need a drink. You know what this reminds me of also? Osmotic pressure. Osmotic pressure brings air or the fluid back into the capillaries. Just how I use pressure to bring it back up the straw into my body. That is what osmotic pressure does as well.